All right, here we are into section 1.5. This is continued from what we've done previously, but this will be our last section for week 2. And this is actually, I think, the easier of the methods that we learned about on how to solve quadratic equations. If you recall, we first did it by factoring. Then we did it by the square root property, where we were square rooting both sides of the equation. And then we did it by completing the square, which completing the square by far would have been the most difficult. Okay, so we are going to do the last way to do this, and this is by the quadratic formula. Notice that it is just a formula, okay? So that's what a lot of students like, is that we can just plug in numbers with this formula. So the solutions, which are their answers that make this equation true, of a quadratic equation in the general form, ax squared plus bx plus c equals 0. Notice that part right there, equal to 0, with a not equal to 0 are given by. Now, it is a big formula. I'm going to write it over here kind of so I have enough room. But there is kind of a song that goes to it, and I'm not the best singer, but I do know that a lot of students do kind of remember it by a song. And so let me write the formula down, and then I will somewhat sing it for you, but no judging. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you may want to ask what a, b, and c are. Well, we come back to our equation. There's where a, b, and c are. They are the numbers in front of the x squared term, the x term, and the constant. Now, the equation must be equal to 0 before starting. So make sure that you have it equal to 0 if it is not already. All right, so look like these first three right here are already equal to 0, which is nice. So here it is musically. It goes to kind of, I do it by Pop Goes the Weasel. There are other versions that teachers do, but I learned it by Pop Goes the Weasel, so that's what I do. So here it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so you can sing it if you want, but that's a way to remember it as well. Okay, to memorize it. So let's do the quadratic formula with these three equations so that we can, and if you're one that writes big, you may want to write small, because I had to kind of squeeze mine in here at the bottom. So here we are equal to 0. Notice I'm going to let this be a, let this be b, and let that be c. Now if a number is negative, make sure you take the negative with you. So I'm going to scroll up just a little bit so we can see the formula. So we're going to go x equals the opposite of b. Well, it's a plus 9, so let's do a negative 9 for the opposite. Plus or minus the square root of b squared minus 4 times a times c. So I'm just going to write those out. Most of the time I just write those out just so that I don't do a multiplication in my head wrong. All over 2 times a, which is 2. And now, those are our solutions. We just have to simplify that. So it's not really like there's a process or anything. It's just a formula you have to memorize and work out. So let's go negative 9 plus or minus. Now, I'm going to work with this piece right in here. If I do 4 times 2, that's 8, times negative 5 is technically a negative 40. But notice that you have a negative times a negative here, which would become a positive, okay? So I would have, I'm going to rewrite this for you. Don't do too much in your head. I end up getting 81 when I square the 9 plus 40 all over 2 times 2, which is 4. Now, here, 81 plus 40 is my next step. Then I have to simplify and add those together. And that actually gives me a 121. And I'm doing a lot of little crossouts here to save a little bit of space. Now, square root of 121 is a very special number because that's actually a perfect square. So I'm going to rewrite negative 9 plus or minus the square root of 121. What do we square to get a 121? It is an 11 all over a 4. And now, since that's a perfect square, we can actually go and find the two answers that make that true. So negative 9 plus 11 gives me a 2 all over 4. And negative 9 minus 11 is a negative 20 all over 4. Now, each one of those I can reduce. This I'm going to reduce to 1/2, so that's one answer. And this I can divide out and give me a -5, and that's my other answer. Okay, so those are the two answers. Sometimes we'll leave them all together, which you'll see in the next one, as one fraction. Okay, so let's try this guy. Let's let this be A, let this be B, and let this guy be C. So let's do the opposite of B. So let's go x equals -b, which gives us a -2, plus or minus the square root of b squared, which would be 2 squared, minus 4 times A times C. Now C again is negative. Be very careful there. All over 2 times A, which is 2. And now again, we've plugged into our formula. We now just need to work it out and simplify. So let's go -2 plus or minus the square root. Let's see if we can do this all together. So here this gives me a 4 minus, I'm going to write it up here. 4 times 2 is 8 times -1 is a -8. So be careful again, that now becomes a plus. So I end up with 4 plus 8, which is 12, all over a 4. When I multiply 2 times 2. And we can simplify this. There is one of those perfect squares. We've done that numerous times before. So I'm going to split that as the square root of 4 times the square root of 3. So this equates to -2 plus or minus square root of 4 is 2 on the outside, square root of 3 on the inside, all over 4. And we have to check to see whether or not we can cancel. And notice there's a 2, 2, and a 2 that's all in common in all 3 spots. You have to cancel in all 3 or don't cancel any. So I'm going to divide everybody by a 2 and make that a 1, that a 1, and this one a 2. Therefore, my final answer will be -1 plus or minus root 3 all over a 2. And that will be my final answer. Okay? All right. It's like in slow-mo, I don't know why, but it is. All right, last example. Notice here I have x squared minus 4x plus 29. It's equal to 0. That's good. I don't have a number in front, therefore my A is 1. My B is -4 this time, and my C is 29. So make sure that you be very careful there. Let's go x equals -b. That becomes a +4. Plus or minus the square root of b squared. Whoops, I was going to write a B. I should write a 4. And actually a -4. Okay, so that would be a -4 squared minus 4 times A, which is 1, times C, which is 29, all over 2A. 2 times 1. Okay. All right, so we need to simplify on the inside, but that's okay. We can do that. This here gives me a 16 minus 4 times a 29 gives me a a 1/16. So I have 16 minus a 1/16. So I'm going to come back here and put whatever that is underneath the square root. So that ends up being a -100. All over 2 times 1, which is 2. And now we have a square root of a negative number. And we just saw in section 1-4 where that's going to be an imaginary number, which that's okay. That negative comes out, makes that an I. And the square root of 100 is a 10. So let's go 4 plus or minus 10I all over 2. And notice all 3 of those have a common 2. So again, cancel all of them with the same thing. If not, don't cancel at all. So when I do that, when I divide everybody by a 2, this one's not going to matter. So I'm just going to be left with 2 plus or minus 5I as my final answer. Okay? All right. Very, very good. Hopefully that kind of works with those. That kind of gives you one of each type, one where you have problems that you can kind of simplify, one that leaves it as one fraction, which is probably more than likely the idea that you're going to have left as your answer. And then here we have an imaginary as well. Okay. All right, now let's look at that b squared minus 4ac as something that can help us determine. And I use this a lot when trying to solve some problems because if b squared minus 4ac is a certain number, that means that my equation can be factored. And once you get used to factoring, that's kind of the easiest way to solve an equation. But this little exercise is going to kind of teach us on what kind of roots will we end with out of that equation. So if I go back one page and I look at what we just did at the bottom, these are rational numbers, okay? So we would have rational roots. This is an irrational root or roots, and these are imaginary roots. Now the only one I don't have here is if we had a 0 underneath here, and that would just mean that when I have a double root, I have the same number occurring twice. Okay, and we can determine the kind of roots or the nature of the roots just by looking at the expression b squared minus 4ac. Now that was what's underneath that square root in the quadratic formula, and that is what we call the discriminant. Some books represent it by a D, other books just call it the discriminant, okay? So the types of solutions for our quadratic formula, there are basically 4 choices. We're going to look at b squared minus 4ac if it is a positive number greater than 0. You may want to put a positive here or something like that. What happens if I have b squared minus 4ac equal to 0? And what happens if I have b squared minus 4ac which is less than 0? So it would be a negative number, okay? So I have a positive number. So maybe it kicks out at 36. So 36 is actually a perfect square. And that's what's going to happen for our first choice. We are going to have 2 unequal real rational roots. 2 unequal real rational roots if the discriminant is a perfect square. So the number I kick out could be, 1, 36, 64, 100. Okay, those are all going to kick out those real rational roots, just like the first example that we did with the quadratic formula on the reverse side. So here, if I have irrational roots, that means that we do not have a perfect square. So we have a number like 34 or 99 or 56. Those are all not perfect squares. And here we're going to have 2 unequal real irrational roots. Now the order they may do it, they may say 2 unequal irrational real roots or whatever the case may be, but make sure you have each of those pieces. 2 unequal real irrational roots. Now, if I have b squared minus 4ac, all that underneath the square root equal to 0, then there is going to be 1 real double root. It is going to be like one of those quantity squares that occurs twice when we were to factor that. And that would actually, the ones that are factorable, just as an extra side note here, if you get a perfect square or a 0, those equations are ones that can be factored, okay? All right, and then if we have negative numbers underneath the square root, so we have like square root of negative 100 or square root of negative 7, those are going to give us 2 unequal imaginary conjugates. Okay, 2 unequal imaginary conjugates. So we are just going to, in the next 3 examples, and note, make sure the equation is equal to 0. Make sure you're equal to 0 on each one of these, just like with the quadratic formula. We need to determine what the discriminant is. And from that, we need to decide what kind of roots do we get. And this would be our choices up here. Okay? So first I'm going to look at b squared minus 4ac. This right here is A, this is B, this is C. So all we have to do is square the 11 minus 4 times 2 times a negative 6. be cautious on those negatives back there. All right, so we're going to go 121 for the 11 squared minus 4 times 2 is 8 times 6, and a negative 6 would be a negative 48. Notice there, I've got a double negative, so that becomes a plus. And when I add 121 and 48, that gives me a 169. Now the question is, first off, is that positive, 0, or negative? Well, obviously it's positive, so we're up here in number 1. So we're either going to have 2 unequal real rational roots or 2 unequal real irrational roots. And it all determines whether or not it's a perfect square or not. Question is this a perfect square? The answer is yes. The square root of that is going to be 13. It does give us a whole number. So this is going to give us 2 unequal rational real roots. And that would be our answer. If they just want to know what kind of solutions that I have, then you don't have to go and actually find the solution. You just have to tell what kind that you have. Okay? And again, that's by looking at what is b squared minus 4ac. So let's try this one. b squared minus 4ac is going to be, take this negative 2 and square it, minus 4 times 3. So write it all out if you have to. Negative 2 times negative 2, anytime I square a negative, I become a positive, minus 4 times 4 is 16, times 3 is 48. Therefore, when I subtract them, gives me a negative 44. And in this case, I don't care what the number is. I just want to know what the sign is. Is it positive, 0, or negative? We are in case number 3 now. It is negative. Therefore, we're going to have 2 unequal imaginary conjugates. So we're going to have 2... Oops, I forgot the unequal. And because it's being slow, I'm not going back to rewrite it. So you could put that in there. 2 unequal imaginary conjugates. And so on your homework, I'm not sure if they will give you choices or if you have to write that in. But you should be able just to choose that imaginary conjugates for the answer. Okay? All right. So let's try this next one and the last one. There is our a that's invisible. So if I look at b squared minus 4ac, which is all underneath that square root, I'm going to take this negative 4 and square it. Minus 4 times a times c. And it's nice c is not negative this time. Oh, just like last time it wasn't negative. And so we're going to simplify this down. Square first, then multiply. So this gives me a 16 minus 4 times 1 times 4 is also 16. Well, that's awfully nice. That gives me a nice 0. And this would be the third case where we would actually have one real double root for our solution. Again, make sure that you don't solve it all the way down. We're just looking at what is the kind of answers that would work in that case. And that's just by looking at the discriminant. So adding on just a little bit of information there. Again, there's a lot of stuff kind of being hit at you all at once. But remember, we got to get through a whole section or a whole curriculum in 8 weeks. All right, so the last 2 problems are dealing with word problems, applications of quadratics. And so we are going to look at this first one, which talks about a rectangular park is 6 miles long and 3 miles wide. How long is a pedestrian route that runs diagonally across the park? Okay, so I'm going to draw a rectangle. Always draw a picture if you can. It is 3 miles wide, 6 miles long. And how long is a pedestrian route that runs diagonally across this park? So a diagonal of a rectangle in geometry is this guy. We're looking for that piece right there, which is x. Now, the question would be, how in the world am I going to solve this? Well, there's things in geometry that you learned that you should have a prereq for, that I should be able to remind you about and you know how to do. And so hopefully you notice there's a right triangle in there. So I'm just kind of honing in on this piece right here. This is a right triangle right here. Okay. And that right triangle has a property. It's called the Pythagorean Theorem. And I'm going to do it over here on this side. Given a right triangle and having legs A, B with a hypotenuse of C, the Pythagorean Theorem states that given two sides, you can always find the third by a squared plus b squared equals c squared. And so that is what we're going to use here in this problem in order to figure out the answer for how long that pedestrian route is diagonally across the park. So I'm going to end up labeling, so here again is my right triangle. The two sides that form the right angle are what we call the legs. So I'm going to call that one A, call that one B, or I could call this one A and this one B. But always the side across from the right angle has to be C. Okay, the longest side is C. So using our Pythagorean theorem, I'm going to go A squared plus B squared equals C squared. So let's go 6 squared plus 3 squared is our x squared. And there's our equation, but we want to solve for x. We have to get x by itself. So I'm going to go ahead and square, then add. So let's go 36 plus 9 equals x squared. Put these two things together gives me a 45 equals x squared. And this is an exercise on how to undo that square, where I must square root both sides. It is the easiest. Square rooting both sides would give us our answer. Please do not forget that plus or minus on that left side. Now let's talk about 45. Let's simplify into our simplest radical form. We're going to write that as a perfect square times something of 1, 4, 9, 16, 25, 36. Which of those goes into it? Hopefully you're telling me 9 times 5. So square root this gives me a 3 and leave that as is. So this would be plus or minus 3 root 5 equals an x. Now we're talking about a length. And so we have to be mindful. Technically, plus or minus 3 root 5 is our answer, but the answer to this question, when we apply that, just has to be the positive root. And we are in miles, so I just choose the positive and not the negative because distance can never be negative. Okay, but when solving that equation, you do get two answers. But our final answer here is 3 root 5 miles, to be exact. Okay? All right, and then we get another rectangle here that we need to figure out the dimensions for. A rectangular parking lot has a length that is 3 yards greater than its width. The area of the parking lot is 180. So hopefully you remember when we worked with linear equations, we had things about perimeter when we were doing these types of problems, but now we get to area to be able to solve a quadratic. So it says that our length is 3 yards greater than our width. So which one do we need to know first? Has to be this guy at the end. We have to know the width first, okay? So I'm going to let the width be x, and if my length is 3 yards greater, that means I have to add 3 to get that new length. So we're going to have an x plus 3. All right, now the area here is 180. So what is our equation? Well, the area of a rectangle, that would be important to know. The area of a rectangle is found by doing your length times your width. So if I take my x and I multiply it by my length, which is x plus 3, that has to equal the area, which they gave me to be 180. Hence, there's our equation. That's how we're going to solve, and it ends up being a quadratic because when I distribute here, I get an x squared. In a quadratic, that quad might throw you off. Quadratic is actually a power of 2, not a 4. But when I distribute, this is what I get. And if I'm going to solve this, I'm going to end up having to get this equal to 0. So I'm going to subtract this 180 over and get x squared plus 3x minus 180 equals 0. And so the question would be, and since the numbers are bigger, it gets a little bit harder. Is there anything that I can multiply to get 180 that I can subtract to get a 3? Well, the answer is actually yes, okay? So we can actually factor this. But nothing says that you couldn't use the quadratic formula on this to figure out the answer, okay? It just becomes bigger numbers in a sense, okay? So I'm going to split my x squared up as x and x. last sign is a minus, so one's a plus and one's a minus, so you're just going to have to look through factors of 180 to help you out, okay? So actually, when I do this, I just kind of get my calculator and start dividing and see which ones will go evenly into 18 and see if I can find the 2 that subtract to give me 3. The actual factors are 15 and 12, actually. So I need a positive 3, so I need a plus 15 minus a 12. And we go one step further to determine what makes this equal to 0. What number plus 15 is 0? The answer is negative 15. And what number minus 12 is 0? That is a positive 12. Now remember, what is x? X back here is a length. So there's no way it could be negative 15 because we cannot let our length be negative. So therefore, x is equal to 12. Then when I plug that in here, I can get my length. So 12 plus 3 is 15. And so our final answer would be a 12 yards by 15 yard rectangle is my answer. Okay, so the width being 12, the length being 15. And that, ladies and gentlemen, is the end of week 2 on our notes and the end of section 1.5 on how to solve quadratic equations. So it's very, very important. It's an important concept in algebra or college algebra to be able to do that. So until next time.